sets of wheels on both the sides, and the tractor, is employed for certain applications. Just as the rail on the rails, you have the train running, and they serve the society. Our assumption is that the geospatial science and the geospatial technology, they both are equally essential, and their being together, their remaining together is complementary for development of both the geospatial science and the technology, and in turn they probably would produce better applications and better solutions for the society. I am happy that today students of the Department of Geospatial Science and Technology are kicking off their first Geo-Space Tech Fest. I am confident here on they would rise higher and higher by the day, and I would close by saying that students, for you, sky is not the limit. For you, geospace or the outer space is the limit. Thank you.
That was a truly inspiring message from our HOD. Moving forward, it is now my honor to introduce our esteemed speaker for Technical Session 1, Ms. Sushmita Gautam. Currently with SMEC and a former researcher at DRDO, she brings extensive experience in satellite image processing and ENVI automation. Ma'am, we are delighted to have you with us today. The floor is yours, ma'am. You can start, Sushmita.
Hello everyone, my name is Sushmita Gautam and I'm working currently with SMEC for the Central Water Commission project known as Dam Rehabilitation and Improvement. So I'm a GIS specialist there, and previous to that I was a researcher, junior research fellow at DRDO in Chandigarh. So today I bring you the scale with me, that is the ENVI hyperspectral software, and we can see how we can apply some geospatial techniques, some image corrections, and let's see what the today's session can bring. So can I start?
Yes, you can.
Okay. Let me quickly present my screen. So is my screen visible?
Yes, the ENVI portal is visible, software.
So yes, today we will start with the, today we'll go through the ENVI journey, and in this journey we have already shared you the content what we keep going to cover. So this is this is all about me. I'm JRF, ex-JRF, and currently I'm in Central Water Commission. So the theme of today's session is getting started with ENVI. We'll explore the data, we'll pre-process the data, we'll apply some vegetation indices, we'll try to classify our images, and we'll try to automate some tasks. Let's see if the time allows what else we can do with our session. So ENVI stands for Environment for Visualizing Images. It's the ENVI is the abbreviation for Environment for Visualizing Images, and it's a software that is used for in various sectors, like in forest health mapping and in environmental and climate applications, and it has been always also used in defense and security sectors, where for terrain intelligence and target material detection. So there we use the hyperspectral data for material detection, and for terrain intelligence we may use the multispectral data as well. So let's start with our session. We have already provided you the link for the ENVI software, where you can download and install. Installation instructions are also given there, so you can go through it. So our first session is getting started with ENVI. So this is the ENVI software. where this is the user interface of the ENVI, and here you can see the menu bar where all the functions like edit, display, place marks, view, server, help are given. And this is the layer manager. This one is in the left side is the layer manager, where you manage the data layers in image window and you rearrange the data order. This is the image window. The middle portion is the image window where you display the raster and vector data. This is the toolbox where you can see many spatial analysis tools are given for processing the raster and vector data. This is the status bar at the right bottom of the window, where you can, when you process the data or you save the output, the status of the progress is shown here. Here you can also cancel out the already running data, progress of already running data. Then this is the property sheet down left bottom of the window, where basic views and basic geographic information is displayed. So let's set some preferences of the ENVI session. This is our ENVI session. First we'll go to the preferences. Then here we go to the directories, and we'll set the input directory. We'll just click the input directory over here, or we can use this button here, and we will set the input directory as the directory where we have saved the data. So it's in C, it's in my downloads. So I'll set the ENVI journey data folder to my input directory, and for output directory, I'm going to save my output in my D folder, where I have much space, and it is my automatic output directory where my outputs will be saved. So there is one folder named ENVI, and I am selecting this folder. Here are some display options, where some display general options are there, where you can set the zoom interpolation method. Here you can select the option as nearest neighbor, because when you zoom in your image, some pixels changed, and the best option for this is the nearest neighbor option. Then let me check. Okay. Then file preferences, display journal. Okay, we have already set this, and okay, we can click the OK button, and the preferences are set. Here in toolbox, and we provide various tools for analytics that process image data information. You can expand all, or you can collapse all. You can expand all to see the various kind of toolboxes available. You can collapse all, and if you want to add a specific tool to your favorites, you can just click to the tool group. Like I have chosen the spectral, and I'm right now, let's make the vegetation one, any of the, like vegetation index calculator. I'm going to right click it, and I'm going to add to favorites. It's going to take a little time. Then I'll check my favorite at the top. I'll quickly expand it, and I'll see my favorite vegetation index calculator has been added into the favorites. So let's try to open one multispectral image in our ENVI software. So we'll quickly go to the file menu, and we'll click open as one optical sensor. We'll choose the topmost option for this optical sensor, and we'll go to the European Space Agency, and we'll click Sentinel-2. Now this is my folder where I have saved the data, and I'll go to the these are the files that I have provided you already, and I have right clicked on it and chosen the option like extract to Sentinel-2 chain detection, or whatever file it's there. So just click to that. before using ENVI, and I have already extracted all the files. So I'm selecting the first ENVI fundamentals tool folder, and I'll opening my data. The file you can see here is metadata mtd msil1c. You can just click it and you can open. Here you can see the data have been opened in true color bands. And we open automatically in the true color band, and you can see here overview is provided. You can just click on it and you can see where your image is lying. The view of your image is lying here. You can drag it and you can see your window is moving, image window is moving. So you can just uncheck it, and here are some buttons given. Like this is the cursor, the select one is this is the pointer. Here is the pan option where you can drag your imagery with the help of pan. And here you can see zoom to full extent. You can click on it and your imagery will be opened in the native layer resolution. So it's the full extent of this imagery. And now we can see what can we do with this. Okay. Let's see what can we do with the pre-processing now. We can create some quick mosaics. What do you know about mosaics? Mosaics are some like we have small tiles and we want to patch all the tiles together so that we have one complete imagery with all the tiles visible. So we use the mosaic option. Let's see. Okay, I have the data here. And there is one folder known as Sentinel-2 preprocessing. I have renamed it as Sentinel-2 preprocessing. Here you can see many data is like 4 different data are given. So we have 4 different imageries, and we'll quickly open it into the ENVI one by one. You can just open in the similar fashion where I have used the file option and open data, or you can just click onto the open and go to the particular step folder and click on mtd and click open. It will take time. It will open in the layer manager where you can right click and load data. Here you have seen that all the three bands like 10, 20 and 60 meter resolution bands have been opened. We'll just remove this 60 and 20 meter band. We'll go to the 10 meter only. We'll go with the 10 meter only. Okay, let's remove this one also. Let's add again. You can just go to the folder, click the same file and drag and drop onto the ENVI. You can see your data manager are opening many files. So you can right click any file that you don't want, or you can just click previously open file. So I'm just closing all the files. As it was previously open, and I'll open again. So I have opened a new file now. and my data manager has loaded. So my data manager now has three kind of bands, three kind of resolution bands. One is 10 meter, second is of 20 meter, and the rest is of 60 meter. So only 10 meter band has been open, where you can see B4, B3 and B2. The red, green and blue band of the Sentinel has been open as 10 meter resolution. For 20 meter, you can see we have B5, B6, B7 until to the B12. And the 60 meter is B1, 9 and 10. Okay, we'll close the data manager. And again, we'll open and other data in the same manner. Okay, now we have opened all the 4 images. Okay. Now let's create a quick mosaic. So we can click on the view button. We can right click on the view button and then we'll choose the quick mosaic. It has already selected the 4 images and we'll just click to OK. It's generating a mosaic and it has removed the files that was opened before. Only the mosaic is visible now. You can see the mosaic is same as the previous 4 tiles that we have added. In the data manager, you can see all the data, but only the quick mosaic the output is a quick mosaic, so the quick mosaic has been added.
Sushmita,
Yes.
can you what are you doing? Can you describe which step are you at for the people who have joined now?
We are doing the pre-processing.
Okay.
We have opened the Sentinel-2 data. We have checked with the ENVI functions that are available in the toolboxes with getting started with ENVI. We are now at the pre-processing step.
Okay, you're doing pre-processing. Okay.
Okay. Yeah. Okay, we have created a mosaic. Now I am closing the data manager. So let's quickly make a subset of data. As you can see, this is a very big data. This is a very big region. So for quickly going to your specific data area of your data, we can create a spatial subset for that. For that, we can go to the file option. We can click to the save as, and we'll click the first option available like ENVI native TIFF DTED. That are the option for the format for saving the output file. So we'll just click on the save as option. We'll select the quick mosaic and click on the spatial subset option. Okay, now we can select our area of interest. Like I'm just for quickly going to it, I'm creating a small area of box into the red. So this is my area what I'm selecting, and it's going to be extracted over the full area. So I'm clicking OK, and I'm going to save it as an ENVI file that will be saved as .dat file. You can see automatically my output directory is open, where which I have already selected in the preferences. So I have already made a pre-process folder. So quickly I'm saving it as subset 1. It's going to be saved as .dat file, as it's in the ENVI format. So the display result I have already checked. So the result will be visible now. As you can see at the bottom right, the progress is showing like the raster file is going to save. So it's going to take a little bit of time, but after that we'll run a atmospheric correction over that. Okay, it's taking a little bit of time. Let's see.
Sushmita ma'am,
Yes.
somebody has asked a doubt that can you please tell us about what are we going to do and what is ENVI actually used for? Like the person Sumit here is unable to understand the tools which we are using right now.
Okay.
The main purpose behind it, basically.
Okay, fine. The main purpose behind ENVI software is today's session is that we are going to start everything from the scratch. We are going to know about the ENVI software, the menu, the toolbox available, and the pre-processing steps that we can apply on images, the satellite images, and then how we are going to do the vegetation indices if we want to extract information about vegetation, where the vegetation is stressed or not stressed. And we can do some image classification where we can classify our data into classes, into classes, or you can do the supervised classification or unsupervised classification by giving or not giving your training data to classify into various classes. And we can do change detection over some imageries, that what are the pre and post event changes that been has happened on our satellite data. We can do the time series analysis, where we can see the changes over a period of time, and we can automate all these steps into one model. So this is the scope of today's session. So you can see now, back to the session.
To inform all, we have a Q&A session at the end of the session. We have a half-hour Q&A session. So आपके सारे सवाल हम उस टाइम पर ले लेंगे. सुष्मिता, आप फ्लो में अपना प्रोसेसिंग वगैरह कर दीजिए, ठीक है?
Okay, fine. So can I begin now?
Yes, you can.
Okay. Back to the ENVI session. We have already created our subset, so we can see, we can uncheck the quick mosaic, and now we will do all the operation on this subset. So this is the subset 1. Okay, and we have created it, and you can see, zoom in into this image, and you can see now small things are visible now, and you cannot you can just ignore this mosaic for generating quick results. So now on the toolbox, we will click the quack option. Okay, we have the quick atmospheric correction, and for quick atmospheric correction, it is the simplest atmospheric correction tool in ENVI, and it accommodates a wide range of atmospheric and solar conditions as long as the image contains a diverse variety of material. So it is just to eliminate the bad effect of the atmosphere on the image, like there are some clouds, or there are some water visible, or other, like other atmospheric noises are there, so we can just eliminate that by using quick atmospheric correction tool. So we are going to use our data. The data we are going to use is the subset 1. So we are going to click on that and we're going to select OK. So we are going to create a virtual raster as it will not be saved. The sensor type we can select here as a Sentinel-2 or the any NIRs where you can click and click OK. It's taking time. It's doing the correction. So we can just learn about some atmospheric correction and surface reflectance thing. That some applications that analyze reflectance properties or materials require images that have been corrected for atmospheric effects and calibrated to apparent surface reflectance. Both are these steps are required if you will use library reflectance spectra to associate hyperspectral images pixels with known materials at the surface. There are like four types of methods for this for atmospheric correction: the internal average relative reflectance, empirical line calibration, dark subtraction, and quick atmospheric correction. So you can go to the ENVI website for these kind of atmospheric correction if you want to know more. But here we are using quark atmospheric correction. So you can see a quark atmospheric correction image has been generated. And if there would be any noise due to atmosphere, it will be subtracted. It will be eliminated, and we have the quark atmospheric image available here. Okay, this was the pre-processing step, and now we can do some let's see how we can create a vegetation index. Okay, for vegetation indices we have already a file available. Let's go to that. We're going to open the this sentinel-2 denver any.dat. It's available here in your data vegetation indices folder, and this is the one. You can go to it and just just go quickly and drag it on the ENVI software. Here you can see it's this portion of the data, and we are going to use the pan option here, or you can just click the full resolution, or you can just pan or zoom in. Okay. Now, okay, apply a feature mask, or you can just go without a feature mask. Just go to the spectral indices toolbox over here. Okay, just double click it, and you're going to select your data. This is your data, like then Denver northeast.dat sentinel-2. You're going to click OK, and you'll see that there are different type of indices present over here in the drop down or in the list of this index. Just you can create one like NDVI. Normally this is the normalized differential vegetation index. So you can just see here if it is available. Okay, we'll select the normalized difference vegetation index, and we'll create the virtual raster for this, and we'll click OK. So you can see the spectral index image has been generated, and the portion that is in white are uh, the ones that are having the highest NDVI value, and the portion in black are having the low NDVI value. Okay, we have created an NDVI image, and for the area that are having the value of NDVI ranges from -1 to 1. So the pixels that have value less than this 0.1, that are water, barren rocks, and sand and snow. So the values corresponding to 0.2 to 0.5 may be sparse vegetation like shrubs and grasslands. And from 0.6 to 0.9, it is going to be dense vegetation like temperate and tropical forests or crops and at the peak growth stage. So this was the NDVI, and it was the broadband vegetation index. Here we only use the broad bands, not the narrow bands. The broadbands that were available was the red, and the, like for an image, the broadbands are red, green, blue, and NIR. For narrow bands, we use the SWR bands also. So this was the spectral index available, and we use the NDVI option for that. For some narrow band vegetation, you can use a data hyperspectral data for creating narrowband greenness index. So today's session is only limited to the multispectral data. So we have generated a broadband vegetation index with the help of NDVI. Now we have explored the vegetation index. Let's do the image classification. We are going to perform a unsupervised classification first, and with the help of ISO data and k-means, unsupervised classifiers. And the ultimate goal is to create a land cover classification map. You will use unsupervised classification for that, and you can use unsupervised classification to perform a quick land cover classification if no ground truth data are available for the scene. However, the result must be less accurate compared to the supervised classification, because that uses the training data, and the samples are of known classes. So for this, we are going to open a Sentinel, again our data. For that, we're going to go to the open option, and we're going to choose the classification folder for that, and we're going to click the .dat file for this, the Denver reflectance clip.dat. And we're going to open this. Okay, we're going to uncheck all the other thing, and we're going to right click it and zoom it to the layer extent. So you can see a true color imagery is added, and it is at the 100% zoom in ratio. So okay, now we are going to run a ISO data classification. Just quickly go to the toolbox and write ISO data. You can double click it, and you can choose your data for this. Okay, and click OK. If I think this is going to take time, so just you can also create some spatial subset for this by using the image option, and you can make a small square, or just adjust this square to some smaller portion over here. I'm using a center portion and clicking OK. So I click OK here, and now I'm going to select OK for this. Okay, so the number of minimum classes here are like I'm selecting 5, maximum to 10, and I'm giving my output as a memory option, or I can also save it, but let's save it to the memory option so that it doesn't take much time. So I'm going to click it OK. So it's creating a ISO data classification image where the land cover will be visible, land cover classes will be visible. So here you can see your land cover classes has been added. We have given only 5 classes. We can also increase or decrease the classes. So all the different colors corresponding to different classes. Like we have generated 7 classes. Minimum was 5 and maximum was 10. So it has created the 7 classes and one unclassified class is there where the data is not present. So here you can, this is the unsupervised classification where you don't have provided any training data to your class. Let's go to the K-means option. K-means classification. This is the another type of classification that is also unsupervised. So we are going to use our Denver DAD data and we are going to apply spatial subset for that. And now I'm using my one of my image for that. I'm using the same file that I have generated. It is saved in the memory. So I'm clicking the memory option for the extent. I'm clicking OK and it's going to take the same extent as the previous classified imagery. So here the number of classes are 5. I'm going to increase the number of classes to 7. And I'm taking the threshold percentage as 2. And iteration and 1 and everything remains the same. Just click memory and click OK. Here you can see similar K-means have similarly classified the image as the ISO data. So here it was the ISO data and here it was the K-means. So these were the unsupervised classification available. Now let's move to the supervised classification and how we are going to do this. We are going to uncheck these. And this is the Denver data that was available on which we have done the unsupervised classification. So when you are familiar with an area covered by a scene and you know what feature it contains, you can perform a supervised classification. You must provide examples of that data you know with great certainty. With great certainty contain the feature you are interested in. The process of collecting training data, also called ground truth, means that supervised classification is a manual process where you oversee classification. Okay, so training data can come directly from image pixels using region of interest. The image here show the the image here show the option for new region of interest. Here you can provide the region of interest by selecting appropriate options. Like if it is a built, okay. Like there are roofs, there are water, there are land, roads. So you can quickly give the region of interest for that. The traditional supervised classification classifier available on maximum likelihood, minimum distance, Mahana-Lobis distance, and spectral angle mapper. So these are the things that you can explore on the ENVI website. Now let's prepare our training data. Okay. So this is the option given. When you right click your Denver imagery, here you can go to the new region of interest, and there this option becomes available. So I'm doing it again. Right click this, click to the new region of interest, and use your polygon. You can use a rectangle, you can use a circle. Like if I'm going to make a circle over here, it's going to add a region of interest. I'm deleting it. I'm using a polygon. So I can see here some water body. I think it's a water body. So I'm making a polygon over here. I'm double clicking it, and it's making me a polygon for water. Here I'm adding a polygon again. So I'm adding this much of region of interest. Okay, here you can see a polygon available for water. I can see it's a water. You can provide training from the image. You can see the number of record count is going to increase as a data you are taking. So I have taken 3 polygons. I'm naming it as water. And I'm saving it. Okay, I have saved the ROI as water. And then I'm going to put new ROI. My water, you can see it has been saved here. Now I'm making some roads ROI. Roads are linear features, so I'm taking it as a line. Wherever similar class is available, I'm going to click it and I'm going to add the ROIs. I can see here also some roads are available. I'm going to add these ROIs on the image. Okay, let's just take this much of ROI for the sake of time and just make a new ROI. Now you can see here some land is available. So I'm clicking and I think it's a soil. So okay, just delete it. Take a polygon maker and just click it. Here you can make as much as polygon you want and make it as soil. Click enter. Okay, now okay, I've just deleted it somehow. So make it again. I'm making it as soil. And okay. Now any other built-in feature you can give, like I'm making some squares. These look like roof of a building, so I'm giving them as a built up class. I'm clicking it and I'm saving. I'm saving these ROIs as a file also. I'm clicking all the ROIs. I'm going to select all the ROIs, like 5 ROIs. Okay, this soil class is repeated. Okay, I'm just taking one of the soil class. Okay, I'm going to save it as a .xml file. So I'm going to make a new folder and classification. Going to click it and I'm going to add ROI. I'm going to save it. Click it as OK. Or you can make or many classes that, like you want to add some vegetation over that. So here some vegetation is not clearly available, clearly visible. So let's run over these many classes. So we have made the ROIs, and now we are going to use the classification workflow. So just close this box, and on the toolbox write classification workflow. Okay, it's there. I'm going to double click it. All the changes. Okay, just click yes to the ROIs and already save. Cancel it. We have already saved it, so we don't want to save it as a new file. Just click the classification web. Okay. Just save it again if it is asking, but I don't think it asks many times. So just click OK. And now the classification workflow is visible. So we'll choose our raster. We have the clip.dat one, Denver reflectance clip.dat, and we're going to click OK. We're going to click next. So we are going to use the training data here. You just click on the use training data, click next. And in this training data option, you can see your classes are available here. Just delete one of the soil as it will create confusion. So I'm going to click that, close that soil ROI. And now 4 classes are available. So I'm going to click next. This is just a demo of how you can use the tools available on ENVI. And let's see if you can make some confusion matrix to analyze the result of the classification we have done. It's taking a little bit of time. So you can see where our image has been classified, and it's giving some cleanup option like enable smoothing, enable aggregation and all. The classes that we have given color was water was in this red, and built up was in blue, light blue, cyan blue, and this yellow color was soil, and the roads are visible in green color. So wherever there would be rows in the classification, they have classified. So they have taken it as green. So let's make these changes as take it as default and click next. Okay. So we can also go back. Here it's the option available to save the output. So you can save your output as well. So if you want to see which classification algorithm you have used, you can go back also. And I think it was maximum likelihood. Okay, the algorithm portion we didn't explore. Okay, here the algorithm, when you go to the training data, you can also select the algorithm. So we have just created the Denver, the maximum likelihood. Here you can see spectral angle mapper and other classification algorithms are also given. So you can go through those algorithm as well. We have just created the maximum likelihood classification land cover image for that. So it was all about the supervised classification. You got to know about how to create training data and how you have created the land cover image. So just let's go to the maximum likelihood only, create the result and save it to a file. Here are also some option available where you can after you have created your ROIs or your classification image, you can save all those image classification classes to a vector also, like shapefile, so that you can use it for other analysis. So it's taking a little bit of time. Okay, next. These are only the refinement over your classification. So you can take the window size for smoothing as 3 cross 3, and others are like you can explore on the NB website. Okay, you can save your classification vectors also here as a shapefile, and you can save your image as NV. So my output directory was saved to DNB classification and it's taking it automatically. So I'm also selecting this statistics option. So this text file will be saved and I'm saving everything. So I'm clicking finish. Okay, after this classification is been saved, we can take 5 minutes break and we will quickly come back. Just wait for this to save. You can see it's taking it's exporting result. So here we can take 5 or 10 minutes break. I'll hand over my session to Kamini for taking a break.
Okay, we can have a 5 minutes break if you're tired. We will be back in 5:05. Okay, at 5:05. Okay.
Yes, we'll be back.
Okay, Hitesh, can we have the poster? Break poster. Hitesh, let Sushmita present.
Okay, we are back. So let's see, we were doing the classification. So yes, you can see on the screen, the shapefile we have exported are visible, and the maximum likelihood classification has already shown its result. You can see your output result on the output directory that I have taken. So you can see here all the vectors of the classes are available, and the classified imagery is also available as class.dat, Denver reflectance clip class.dat. So that is what supervised classification holds. So these were also basic steps that you can explore on ENVI website, that how you can classify through unsupervised classification or supervised classification, how you can create vegetation indices. The main the main excitement or curiosity, or you can say the relief point where we are relieved from manual task and everything to selecting one by one, we can also automate all the tasks by using the ENVI modeler function. So let's see how automation in ENVI works. So uh, for automating the ENVI, we have a ENVI modeler available on the ENVI. So here you can see on the display, you can click on the ENVI modeler, and it's querying some task. Okay, one thing I should tell you, it uses the ideal functionality of the ENVI, where the programs and in the background in the ideal programming language goes. So what we can do here, you can just minimize this thing. This is the ENVI modeler that has opened. So it was ENVI 5.6 I have used. Here, this option I have used 64-bit. For using the modeler thing, you can use ENVI plus ideal. Okay, so I have already opened the ENVI plus ideal option. So I'm closing this one, minimizing this one, and I have opened this thing. This is ENVI plus ideal. You can see the ideal workspace here. This is the different window. So here different data is already available. So let's see how we can use the ENVI modeler here. We can go to the display option. We can click the ENVI modeler, and here it's querying some tasks. It's like taking a time. Let's wait. Okay. So yeah, it already been opened. So you can see there are some basic node option given, and there are some tasks given. So you can select your tools from there. These are the tools that actually perform the function, and these are the basic nodes, like how you are taking the input file, or you can providing a iterator for looping over same kind of task with different files, or you can provide input parameters together. So let's perform a classification task together. So let's do the ISO data again. You can search on ISO data classification, click on it, and quickly drag and drop here. So similarly, you can take one more tool, like let's say classification smoothing. I'm clicking it and I'm dropping it here. And the main functionality of this ENVI modeler goes with the help of nodes and connectors. So these are the nodes. And the plus sign, you can see it helps you to connect. So when I click it here, you can see it has been connected. So we have nodes and we have connectors. So let's take some data file or some file data set as input. I'm taking a raster as input. I'm selecting one of the raster, like say this 28 Jan 2024 one, and I'm clicking OK. So I have taken one file, and now let's take view as an output thing. You can connect all the things together. You can also select another file with the help of these parameters. These are the parameters. You can click it. You can give as much of number of files you want. You can click it as give it as an output raster also, where you can save your data. Similarly, in classification smoothing, you can give the kernel size. This is the window size it will take over the images. Like it's 3x3 here. Okay. Here in the code option, you can validate your model. So just click it. It will tell you if there is an error, or if there is no error, you can just go and quickly run the model. So here it's saying your model does not have any errors or warnings. So we can just click OK and we'll run our model. So you can see that ISO data classification is going on, and some classification smoothing will go after that, and we can view a result. So now you can see the ISO data classification has been done over this data. And when you can click this, you can, or you want to save this raster, you can just go to the file option and save as, and click the save as option to save your output. Okay, I think this has not been saved yet. You can click the explore layer as step, and you can save it to wherever you want. So I'm just clicking cancel. So this was about the automation thing. If I can tell, you can also automate many things like using batch processor. I don't have the batch option over here, so for this ENVI, but batch processing also use the iterator thing. So here you can see the iterator. You can use it, and you have the input imagery, input parameters. So with the help of these two, you can add as many input, like it's saying that you don't have the access right now. So if you want to connect it with other variables, so you can quickly choose your ISO data classification as some parameters to the input parameter, and you can also give this to this by clicking output raster. Okay. So you can see my iterator is not right now functional. So this version is right now not using my iterator option, but you can explore using the ENVI website, whatever you want to model and whatever how much data you want to take. So you can see these are the functions available in the input parameters. You can give as much as files you want. and iterate over as much as times you want. So this you can select all the files together and run all the both of the tasks together and save it as a data set or save it in the data manager. You can take the basic nodes, you can explore all these functionalities, and also you can save this as a file. So you can click save as and give any name, like I can give it to my model 2. I'm going to save it and save, and if I close it and I input my model again, as let's see if it's inputted. Okay, it's now take it as a model file and we can open the same model again. So this was about the ENVI modeler. In the automation tasks, you can explore more with the help of many data you can, and you can go to the ENVI website. So this was about the automation task. So I think this. I think you can explore the hyperspectral imagery as well on the ENVI website, and where you can create more like vegetation indices. Let's me tell you about hyperspectral indices. We have not explored the hyperspectral data, but if you want to create more vegetation indices like narrow band greenness, so here you can take these much of indices by using your hyperspectral data, as hyperspectral data has more SWIR bands, SWIR bands. So they can be used for these much of vegetation indices, and you can explore, and you can also explore the atmospheric correction on hyperspectral data, different more than any the one we have uh, presented today. Like we have used the quack atmospheric correction, you can go to other atmospheric correction options with the use of hyperspectral data. So let me end my session with this, and we can take some QA queries. Over to you, Kamini.
Okay, what about the time series and change detection part?
The time series and change detection part is going to take much time. We cannot cover it right now. So what I
Can
can
you
do
introduce it little bit?
okay, fine. I can tell something about the time series and this change detection. Okay,
Because we do have time, so
okay,
you
okay,
can tell.
fine. Okay, so the primary objective of chain detection is uh, to observe changes with the help of images, the pre and post events. So like if there is an event like flood is there, so what happened after the flood and how the changes occurred, with the help of imageries we can see. So changes on earth surface can include any number of events, but some includes the long term processes, some are short term, some are man made events. So basically, the chain detection is the process of identifying, describing, and quantifying differences between two images. So for the same geographic area, obviously, the two images should both reflect similar observation condition, close in the same year, or in the same season, or in the in the same season in different years. Like we want to know about the how snow is occurring in Januaries of a geographical region in 2022 or in 2023, or how much rain, how much vegetation is there in particular kharif season in 2022 and 2023. So these are the things that we can do with change detection. Uh, so
Can we like discuss more applications of change detection, like uh, or like it is used in military target detection, and what are like various industries doing with change detection tool and with ENVI?
the industries can use change reduction in disaster management as well, like when when any disaster like landslide occur or any avalanche occur, what was the scenario of that area, of the of that geographical area before and after the event. So we can see the slides, we can see the condition of that area with the pre and post images. So
Anything in agriculture?
agriculture, yeah, you can see about the, you can tell about the this seasonal changes, seasonal variation over a seasonal variation, and do the time series analysis and detect changes over seasons of a particular crop. So and how it is behaving in stressed environment, and how it is how much, if a nutrient is applied on it, how much the changes are available on a particular season or after season. So the agriculture, in many fields we can do the change detection, not only the disaster management or any specific agriculture. We can do change detection in many scenarios.
Any application of ENVI in defense sector? Can you like remember?
Yeah, in defense sector, we can do the target detection using a good hyperspectral or airborne data.
What kind of targets? Like, can you explain to a commoner what are targets and
Targets can be man-made or man-made, or an not or man-made targets can be there, or by means the natural targets can be there. So there can be a material target that we can detect with the use of spectra, or we can also detect the, we can also have the imageries, different kind of imageries to do that. Not only the multispectral, the hyperspectral or the lidar sensor we can use to identify more clearly. And we can we the NV fund, this session is only about the NV fundamentals, so we can also explore the lidar version available for this, lidar option available, and we can also extract feature with that, and we can fuse the two sensor data together for enhancing our information, whether it is spatial or whether it is having some height data, elevation data with it. We can fuse them and may make meaningful result from that. And with the help of these things, we can do we can do a mixing thing, and we can do the spectral analysis, and we can extract information more clearly. So in defense sector there are many things like doing terrain analysis also. So how the terrain is different, how we can run our vehicles on that, how the terrain is available there, like the landform and the elevation available over there. So we can do that analysis for running our tracked vehicle like tanks and all. And the soil analysis, for that we can use these imaging softwares, and so that we can run our vehicle smoothly over those areas. And we can also detect road in undulations, like holes and all, deformation on roads, cracks and all, for urban things. And for this target detection also can be done on camouflage or hidden or occluded things. So there are many applications for image analysts to perform on ENVI hyperspectral software. So yes.
Sushmita, as your topic also included the time series part, so can you like differentiate what is change detection and what is time series? What's the difference, basic difference?
The basic difference here is change detection is done on pre and post images. We have minimum two images, pair of two images, and we are doing event based thing. But in time series, we can do it on yearly thing. Like we can generate graphs, we can do daily and bi-weekly or monthly analysis. So yes, time series is different, and change detection is change detection is basically done for a particular event that has happened. So in time series, we are not uh, we are not just taking one change. We are going to many changes over a period of time. So this is the basic difference between them.
Okay, Neha, you can start. Hitesh, you can put her poster.
Thank you so much, ma'am, for this insightful session. We now open the floor for questions. Participants, please use the raise hand option to unmute and ask your questions, or feel free to type them out in the chat box and we will read them out for you.
So please raise your hand and we will take your name one by one and then you can ask queries.
You can ask your query, Richard.
Madam, thank you for the good presentation. Of course, you have cleared a lot of doubts, but I have some few questions regarding on the presentation that you have been doing.
Yeah, you may ask, Richard. Okay, let's take the next participant, Khushbu Gupta. Please, you can ask.
Hi Sushmita. So thank you for the insightful session. My question is, if we are downloading any hyperspectral data or something, so do we need the type of data which is going to be directly the atmospheric correction, or can we do the radiometric calibration and other GCP corrections also from this?
Yes, you can perform the atmospheric correction using the I can download a Prisma hyperspectral data, suppose, from available satellite imageries online. So I can download it and I can perform atmospheric correction available on ENVI. So yeah, you can do this on ENVI.
So we can do only the atmospheric correction and not the radiometric correction.
You do the radiometric geometric correction by using another imagery. If you don't have the RPC ground look table for your this ground look table data or any other data that associates with your hyperspectral imagery, you can use the Sentinel-2 imagery to quickly georeference your data. So some kind of things can happen with another image, like image to image registration you can do. So this can calibrate your data.
Okay, and is there any kind of document or something for all these things so that we can read out for NV and we can do use for our work?
On website, NV website, there are tutorial available, but if you want us to provide we can give us you can give us like this week time, so we can provide you the proper things we have not covered in this session. We can also give you the proper steps that are needed and proper steps that you can follow with also other kind of data like hyperspectral. So yes, we can provide on the same Google link that we have given you, the drive link. we can provide a document on that.
Okay, and is your email ID is also available so that we can connect with you in future if we need some help or something?
Yeah, let me type it on the chat.
Sushmita, your voice
Yeah,
is not
yeah. Let me type it on the chat box.
Okay, I think Khushbu, you're done. We can move to the next participant. So, Mr. Richard, please ask your question.
Okay, thank you. My question was when Madam began her presentation, she just started with the downloaded image, but she didn't exactly put forward where did she take those images before importing them to the software. I would like to know, how do we get those Sentinel-2 images? How do we
download these space data, but we were more into ENVI software. So yes, for doing that, you can go, if you want to like download this Sentinel-2 data, you can go to this Copernicus hub, or the data space, they have renamed it, the European Copernicus data space website. You can go, like I can go here on Google.
The link is shared in the chat box.
Okay. Yeah, you can go to that data space website and download the Sentinel-2 data. We have mostly covered with the MSI, this L1 data of the Sentinel-2. So these have like 10 to 60 meter resolution. So we have done things on the 10-meter resolution. We have made the mosaics of Sentinel-2 images. So yeah, you can do more with another kind of data like Landsat. You can just go to the Earth space, this Earth data search also, like from NASA and different sources. You can download your satellite imagery.
Okay, Nihar, please read
also,
out
I
the
have
question in the chat.
the last question. The last question. Sorry,
Yeah.
madam. Oh yeah. My last question is on the algorithm that you used. I see mostly you used the machine learning algorithm, which is quite possible for the data set that we had. There were very few. But in current days, we mostly concentrate on the deep learning, of which they require a huge number of images of data to train. How is it possible for this kind of training state? How is it possible for the deep learning?
Okay, the deep learning thing is available in this kind of software also. So as the software is getting updated, see, I'm not a person from the this ENVI software company, but I have explored some functionalities. So nowadays, this ENVI software is getting integrated with the ArcGIS Pro. So both are working together. Like the result of ENVI software, you can export to the ArcGIS integrated. So both are having the deep learning workflows in their software. So you can automate your task. You can just provide training, everything, the deep learning, all the deep learning processes. You can do it in the ENVI nowadays. And then you can also export the result, pre-processing or post-process result to the ArcGIS Pro. And on ArcGIS Pro, you can run your this Python notebooks and do the deep learning tasks. So these software are taking many like huge amount of like relieve you with huge amount of manual tasks, and the thing that you are typing on Google Colab and the already available these machine learning like ResNet and other models you already can use in the software. So UNet and ResNet, they're already available in the ArcGIS Pro. So you can use these things together, NV and ArcGIS, and do the deep learning things nowadays.
Okay, thank you. Thank you very much.
Okay, Neha, you can read out the questions in the chat box.
Yes, the next question is from Biswajit Mandal. He's saying thank you for the session, and his question is how can we generate new indices? Suppose the NDVI option is not listed. If possible, please show us flash FLAASH atmospheric correction using the
Okay, now right now we cannot do everything together, but yeah, you can use the Bathman operator, this band math operator in the NV. It might be there in the NV. I have used in the classic software, but I don't think
It's there, and it's in the
okay.
tools. When we search in the tools, we get the option of band math, and we can put the formula for NDVI there, and we can calculate it. It's very easy. You can create any indices in that tool, band math.
Yeah, exactly.
And about the flash atmospheric correction, there are a lot of videos available on YouTube. We will share a link to you within a minute. Okay.
Yeah, I can share one very important link. Let me share you with the flash this flash atmospheric correction done on the hyperspectral data. Just give me a second.
Okay.
I had applied it on my work, but couldn't produce it here. So I think this is the thing. Okay. Yeah, I'm giving it on the chat box. I have given a YouTube link over there. I think this is the only one that is going to be used on the Prisma hyperspectral data. I have used it, but it's a long process, so we cannot describe everything right now. But if you want the write up of everything, you have given in the chat box, like like the ortho correction and the ortho rectification and geo referencing thing. Khushbu Gupta have asked. So we can provide everything in a document and we can post it on the same G Drive link, so you can check it from there.
Okay, Neha, next question.
Okay, the next question is from Vatsal. He says, good evening, ma'am. Thanks, as I learned many new things today. I wanted to ask about what are the specific sources for getting the databases for making a project and learning NV.
To learn NV, you can go through the ENVI website. Okay, you can go to the tutorial website. You can check many universities are giving this their own manuals, lab session manuals. You can go through them. We can give it when we will provide this document. We will give all the resources where you can learn NV more. So I'll share it on my G Drive. And what was the question? What was the what he asked?
Ma'am, the question is, he wants to ask about what are the specific sources for getting the databases for making a project and learning NV.
Okay. For getting data, you can go to the satellite data, or you can use this Google Dataset website. You can download your data from that. But if you want to follow a particular kind of like multispectral data, you can go to the Sentinel-2, that is 10-meter resolution available, or you can explore the Bhuvanidhi portal, which is 5.8-meter resolution, I guess, less than that of the Sentinel-2. You can download it from there. You can do many things you can do, or you can just go to the sample data of every their satellite that are giving their data set. Like if there is any high resolution data you want for hyperspectral. There are Airbus, and there are other like planet.com. You can make a you can make your profile over there. You can buy some data if you want, but I don't suggest you to buy data, but you can work on sample data. So we can everything. Drive I have shared, I can share the document for other resources as well.
Okay, the next question is from Sumit Sharma. His question is, can we also make maps by using different types of tools from ENVI?
Different type of what?
Tools from ENVI.
I don't think and we have the functionality to make maps. It's not it's image processing software, but making maps, you can export your file as tips and whatever images you can share, but you can do the vector and raster analysis, but you cannot make map. For making maps, we want to export it, you can just export it as a ppt. More you can do is you can just clip your view to ppt, or you can make a image like you can share the image of your session, but you cannot make maps over this. This is not a mapping software. You can just make the classification output of that image, but not maps. For maps, you have to apply the mapping cartographic elements. So for cartographic elements, I will better suggest you do the GIS softwares like QGIS and Quantum GIS and ArcGIS. These are the mapping software. Here you can just do analysis, but there you can make layouts. You can make print layouts, you can make your map layouts, and you can also in ArcGIS Pro, the functionality of map series, you can create multiple maps together. So these much of functionalities and we don't have. So ENVI is a image processing software basically, so it can do the remote sensing stuff better. And for mapping, you can use the GIS softwares.
Okay, last question, Hitesh, you can ask.
Ma'am, earlier you said that NV has also some capabilities of directly integrating with the ArcGIS Pro.
Yes.
So, what you have shown us here, we can also do it in ArcGIS Pro with the help of NV extension.
Yeah, if you have the license or if you have the trial version, you can do it together, like exporting the result directly to an ArcGIS Pro and using it in the deep learning module of the ArcGIS Pro. So like if you have the training data here, you have created many training data here in the deep learning and you want to export it to the ArcGIS, you can directly do it.
So, no, ma'am, I am also asking that what we did here, like user unsupervised classification. So we can also do that in ArcGIS Pro. So but it is only limited to hyperspectral imagery or multispectral imagery or hyperspectral also.
In ArcGIS Pro, you can do you. I don't know much about the ArcGIS Pro for the hyperspectral, but ENVI is really expertise on hyperspectral data. So the time it takes to explore the hyperspectral and view all the bands together, ArcGIS Pro takes much time for this. So doing the unsupervised classification, yeah, there might be option for ArcGIS Pro to do the unsupervised classification, but it depends on the type of data you use. So I suggest that for hyperspectral data, ENVI is good. I have opened the hyperspectral data on ArcGIS Pro, but did not perform many
ये भी
other.
अच्छा है कि पूरी रात निकल जाएगी ट्रेन में.
I have not explored. I have not explored the many options as much as NV has. For like you want to geo-reference your two images. So I don't think this option is much well provided in the ArcGIS Pro, like image to image registration for like two type of sensors like multispectral and hyperspectral together. So also lidar is there. For lidar you have to download like in QGIS you have to download other functionalities, other packages for LiDAR like LAS tools and all. But in ENVI now it is already integrated, so you can do the this feature extraction together with the image and the LiDAR data, and you can fuse it on one platform.
Thank you.
Okay.
Okay, I think we can wrap up the Q&A session, and in the interest of time, we suggest mailing any further questions directly to our speaker. We've already pinned her email in the chat box. Thank you for this very engaging discussion.
Thank you.
Thank you. Thank you very much.
Okay, Neha, vote of thanks.
Okay, on behalf of the Geospatial Society DTU, I extend my sincere gratitude to our respected HOD, Dr. K.C. Tiwari, for his constant support and motivation. I would also like to acknowledge the support and encouragement of the Honorable Vice Chancellor, Dean Students Welfare, Dean PG, Dean UG, all deans, heads of departments, faculty members, the registrar, and all administrative heads of the university. My heartfelt thanks also go to the dedicated committee members, Hitesh, Vaibhavi, Pooja, Vedant, Rajnath, and the entire team for their hard work, and of course to our speaker, Ms. Sushmita Gautam, for making today's session so enriching. Thank you, everyone. You all can share your valuable feedback of this session now in the chat box.
Okay, thank you all participants for joining us today. The recording for this session will be available on our YouTube channel. You all can go and practice skills you have attained in this session from it. We look forward to seeing you at our next session, which is equally exciting. We will be diving into Python for Earth Explorer, GIS basics and automation with our guest speaker Utkarsh Karn, lead software engineer at DFY Gravity, next Saturday at 10 a.m. Until then, have a great week ahead. See you all. Bye-bye. Okay, someone has raised his hand, but you can mail her any query you have.
Hello, ma'am. Just one ask on to one question. Is the
Okay.
session is available on YouTube?
Yes.
So I just said
Will
it.
be
That
on.
session is available on YouTube. We will post a recording on it. Okay.
Okay. Can you please give me the link?
Of YouTube channel, we will mail it to you. Okay. You have registered, right?
Yeah, I registered.
Okay, we will mail it. Okay.
Okay. Thank you. Thank you.
Bye bye. Bye bye, guys.
Bye.
I'm ending the meeting.